Please welcome Larry Ellison.
Oracle Exadata version 2, hardware by Sun and software by Oracle. It is the first database machine that does online transaction processing. All the other machines, Teradata, Netezza, etc., are designed just for data warehousing. Oracle Exadata version 1 was designed just for data warehousing. This is the first time a machine, a database machine, has ever been able to do both data warehousing and online transaction processing. Don't take my word for it. Ask Exadata version 1 customers. Allegro, a query that took 24 hours now ran in less than 30 minutes. Now that's extreme performance. MTEL, every query was faster, between 10 times faster and as much as 72 times faster with that particular customer. Next customer, a query that used to take 30 minutes down to less than 1 minute. So again, performance with Exadata version 1, 10 to 50 times faster than Oracle running a data warehouse on a conventional computer. So what did we do for Exadata version 2? Next slide. It's still, by the way, the fastest machine in the world for data warehousing. That's the third bullet point. In fact, it's twice as fast as Exadata version 1 for data warehousing. But that's not the most interesting thing. The most interesting thing is it runs online transaction processing, something Netezza just can't do at all, something Teradata just can't do at all. And there are a lot of interesting new specialized data warehousing software startups that just can't do online transaction processing, but we can do both. And we do both very well. We are still the fastest machine in the world for data warehousing, but now we're also by far the fastest machine in the world for online transaction processing, because we've optimized random I/O. We can do random I/O very quickly. In fact, you'll see a single rack, this one little Exadata machine right here, hardware by Sun, software by Oracle, can do over 1 million random I/Os in a second. It is the first database machine for OLTP and the fastest computer of any kind for OLTP. It is the fastest computer of any kind for data warehousing. It delivers not only the highest performance, but also the best cost performance in both data warehousing and OLTP. And by the way, if you're going to run big mission-critical applications on this, it's good to know that it is completely fault tolerant. If a network component should fail, it just keeps running. Everything's redundant. If a storage server should fail, it just keeps running. The data is mirrored across storage servers. If a compute server should fail, it just keeps running. We have plenty of extra. So how fast is our Exadata version 2 versus the fastest transaction processing computer in the world? Well, as far as we know, the fastest transaction processing computer in the world is IBM Power, I think it's Model 595, and costs around $10 million. You put the appropriate amount of storage on it to get the high transaction rates. And to deliver the same capacity, the same performance, we need 2 of these Exadata racks, which cost less than 1/4 as much. Of course, if you'd rather go 4 times faster than IBM, than the fastest computer in the world, you go to 8 Exadata racks. And you go 4 times faster. So if you want to spend the same money, you can go 4 times faster. If you want to save more than 75%, just go the same speed. Oh, by the way, one other difference. We're fault tolerant. They're not. We're incrementally expandable on demand. They're not. We believe for a long time that the architecture of the future is scale-out architecture, massively parallel architecture. We've been working on this for a long time, 15 years of R&D, 20 years of R&D in massively parallel computing. It's gone by various names. I guess the current name when you buy the software is Real Application Clusters, Oracle Real Application Clusters. But it allows us to store a single database or manage a single database with lots and lots of computers that don't share memory. And it's an architecture unique to Oracle. IBM DB2 doesn't do it. IBM DB2 on Unix, on Power doesn't do it. SQL Server doesn't do it. No other database, database does this kind of scale out for OLTP and data warehousing. It's completely fault tolerant. Any of the components can fail, network component fails, it keeps running. Everything's redundant. Storage service fails, it keeps running. Compute server fails, the database compute service fails, it keeps running. There is no single point of failure in this box. IBM has nothing like that. Nothing like that. Because this thing is pre-configured, all of the hardware and all of the software is pre-configured, you roll in this box, you load up your data, and you run. You get it in the morning and you're running by the afternoon. This is dramatically different than the usual labor required to assemble all of the different hardware and software components into a configuration, then tune that configuration, get it to work. This is, all the software is preloaded, all the hardware is pre-configured. You roll it in, load up your data, and you run. Hardware by Sun, software by Oracle, the fastest data warehousing machine in the world. The fastest OLTP machine in the world, the most cost-effective data warehousing machine in the world, the most cost-effective OLTP machine in the world. And you get all of that with fault tolerance and scalability on demand. It is the fastest data processing computer that's ever been built. Now I'd like to call up John Fowler, who heads engineering at Sun, to talk about the key Sun technology, the Sun FlashFire technology, that enabled us to build not only a data warehouse machine, but also an OLTP machine. John?
Thanks, Larry. And thank you. This is about integrated engineering, bringing together the network, the server technology, and the storage technology to create something that's quite different to deliver that kind of performance. I know 1 million random read IOPS, I have a technical term for that, out of one machine, and that's ridiculous. That's a tremendous database performance. It's never been achieved out of a single machine ever before, 1 million random read IOPS. So what does that give you? It's tremendous numbers. Like I said before, 1 million random read IOPS is kind of a ridiculous number. If you look at what you get compared to Exadata v1 and against other database machines available in the world today, it's a massive step function in terms of what you can do and what kind of problems you can take on. So with that, I want to thank Larry, partnership with Oracle and the teams for putting this all together.